Okay, welcome back, generals, to another Let's Fix a Generals Zero Out to make the best game ever. We are still developing an unassemblize tool to aid the Thyme development efforts. And what we want to look at now is this assert. This assert, okay. This assert. So we click on compare. And we hit the assert. Okay. E8. 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 Okay, name functions 3, 4, 5. 3, 4, 5. Name functions. Build function name to index map. Function name. Where is this actually used? Ah, it's to compare the names of the functions, yeah. So we have we have multiple I think we looked at it last time already. Here we see functions. It was here. How do we add an item here? Oh, it's locals, right. Okay, here, so 3.9 and 3.10. They both have the same symbol, but with a different address. Poof. Poof. Well, I mean, I don't know what to say about this. If a function has the same name, the PDB reader, PDB tells us it has this name, and it sits at different addresses. Well, I mean, we won't be able to compare this. If it has a different name, then there's absolutely nothing we can do. The only thing we could do is say, okay, well, no, we can't make assumptions about address offsets. No, that just puts it at random. I don't know. Maybe there would need to be a mode where you say it is this or this function. Edit name functions. We just ignore it. I mean, What can we really say about it? Nothing. Well, let me take a screenshot. And then we can send this to our friend Thompson's26 and ask him about his opinion on this. Yeah, I don't know. I don't know. Basically, a function, we would need to have a concept of one function can match with multiples if they have the same name. But currently our logic is not catered towards this principle. So that won't work. I really don't understand why functions can have the same name. I think that is absurd. Like a symbol should have a uniquely identifiable name. Why are there symbols that have the same name? Why? I don't understand. I wonder. 327 minus 4. So this is 19 bytes. And this one is 13 bytes. Okay, so they have different sizes, not the same thing. Yeah. This is not nice. E8. Okay, how many of these hits do we get? Just one. Ah, no, it will stop after one, I think. Let's put a different kind of breakpoint. If not added, then map.clear, I don't know. just do something so I can put a breakpoint. Okay, so it's 1, it's 2, E9, E4, E6, E7. Yeah. Okay, so it's a bunch of E function, dollar E functions, whatever that means. Can we maybe find, let's ask our friends ChatGPT. With MSVC, with a MSVC compiled binary and PDB file, I see function symbols that look like so. E4, E8, E9. What these, they appear to be somewhat special because there can be multiple instances for each. What are these? How are these created? Or what creates these? Oh, let's see if special symbols that appear in Microsoft Visual C++. These symbols are generated by the compiler and used internally for specific constructs. These symbols often relate to exception handling and stack unwinding. MSVC uses them internally to manage exception handling, tables, and related information, especially for C++ constructs that require cleanup, destructors, or try-catch blocks. Each E symbol corresponds to a specific scope or region in the code that is associated with exception handling. Compiler-generated symbols are not directly tied to any user-defined function or variable. Each symbol often corresponds to a unique scope of cleanup code or other runtime tasks that need to be managed by the exception handling mechanism. Multiple E can exist because these represent different scopes or frames. Try catch. Generated by MSC. Usually not relevant for application level debugging. Can be useful when reverse engineering or studying compiler generated structures. And reverse engineering. Okay, sure. Okay, I'm inclined to currently simply ignore these guys. So how about we go to our PDB reader. Okay, makes me wonder what is compilant info used for. Nothing. Okay. I think what we should do is the moment we give our functions to the, to the executable, which we have some function for somewhere. If I'm not mistaken, add symbols here. Add symbols. Here. Symbol name can collide. Symbol name can collide. Is that also because of the E9, E8 thingy? Maybe. So what I think we should do is here, we should ignore these special symbols. So we say if symbol dot name dot do we have a function to starts with C++ string starts with right, I remember this. R finds. Oh boy. R find, what does it take? Const char. Okay, let's add a new util function. Bool starts with const char str sd string as const comparent maybe just operands. Return str.rfind. Does it take string view? Yeah. Comparant 0 equals 0. Is that right? Yeah. It's not very intuitive. Okay, so we say util starts with name $e $e return. Actually, we can make this check right here. There we go. Maybe we should also add some comments here that Let's copy some of the info here. Corresponds to a specific scope or region, the code that is associated with exception handling. MSVC uses some internally to manage exception handling, tables, and related information, especially for C++ constructs that require cleanup, destructors, or try-catch blocks. Compiler-generated symbols are not directly tied to any user-defined function or variable. Okay, this. Multiple E star symbols can exist because these represent different scopes or frames within the compiled binary. Yeah. So use some internally to manage exception handling tables. Server region. Okay, I think this is good enough. Okay, then let's do the following. Let's remove this, and we put symbol name can collide. So I think, hold on. Overwrite, add symbol overwrite. Overwrite, try place. Overwrite. Yeah. Wait, this is correct. Hold on. Add symbol overwrites. Symbols overwrites. Right. Okay, so here we need to say IT2 and place. Okay, hold on. So if it doesn't exist, then we don't really override. Okay. If it does exist, then we would say place symbol name some pushback index. Right. Okay. So I think here it should be just edit one, edit one. I think we don't need to change the maps at all because yeah. Okay, if I'm not mistaken, then this is actually sufficient. Edit one, edit two. Yeah, I hope that this is correct. Let's go to runner and also re-add this assert. Okay, let's put a breakpoint here to see if these are getting filtered. Compare. And we hit some. Oof. Oh, we got some other. Shit. Exception. Exception. Well, how about we put a blacklist on this one as well? Zero exception. Let's see what else we hit. exit. 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 That's not good. Okay, so there are also two exit functions. That sucks. Two exit. Oh, try and place. Try and place. Try and place. Okay, if we take this one out here though, and we just have this, will we at least avoid the other assert? Let's see. Oh, what is this? Oof. Build bundle. Right. Right. Oh boy. Oh boy. Maybe we just need to accept that there will be name duplicates. Yeah. Let's add a comment here to do. Can we avoid duplicate names? Then let's go to runner. Sorry. Where was the other asserts? Asserts. Here. Okay. So this loads. Oh, we got another hit. What is it this time? Huh? That just matches with itself. That's fair. Apart from some. 310. Matched index, none. Yeah. Unmatched index. Unmatched size is 0. Oh. Right. Right. No. Huh? Aha. Okay, I see there is a discrepancy now. Matched functions has captured more Huh. Function name to index. Ah, I see. Oh, yeah. I see the problem. Oh, but it all comes from these duplicate names. They are the devil. The duplicate names are the devil. Bah. Okay, this is a bigger problem. We need to get hold on these duplicates. It destroys logic. It's all built on the expectation that there are no duplicate symbols. Shit. In C++, there is the concept of a multimap. Multiple entries with the same key. Multimap use case. Make it useful in competitive programming. What is competitive programming? Like a hackathon, I guess. Competitive programming. One-on-one programmer. Multi-map. I never used a multi-map. Just crossed my mind. Like, since we have multiple strings with the same name, so maybe a multi-map could be of use here. But then how do we interact with this map if we have a multi-map? So here, 6, 6. So we have 2 6s in here. But then how do you interact with this? I don't understand. Multi-map. Multiple values to be associated with a single key. Duplicate keys are allowed. Yeah. The multi-map is implemented as a balanced binary search tree. Blah blah blah. Okay. Duplicate keys. Multiple keys, same key can coexist in a multi-map. Both map and ordering the elements based on the keys. However, map enforces a strict ordering. I saw an ascending order of keys adjacent to each other. Offers additional functionality with the equal range function. Pair of iterators, which returns a pair of iterators pointing to the range of elements. Aha. Aha. So it gives you a range. Aha, aha. Now the question is, do we need a multi-map or an unordered multi-map? But I'm worried about this unsorted thing. Unordered map, multi-key sorting. So, unordered multi-map key sorting. Let's ask ChatGPT. The unordered how are duplicate keys sorted in a STD unordered multi-map? How are duplicate keys sorted, or do they have no sorting, or do they have no order rule, such as, well, no order rule. Duplicate keys have no specific order. Is implemented as a hash table, so the order of elements depends on the hash function and the way collisions are resolved. When multiple elements have the same key, they are stored in a bucket determined by the hash of the key within the same bucket. The order of elements is determined by the insertion sequence, but is not guaranteed to be preserved reliably in all operations such as rehashing. Okay. No guaranteed order. Duplicate keys are not sorted. If you need a multi-map that maintains the order of duplicate keys, consider using multi-map. Keeps keys in sorted order. Okay, then how about we use a multi-map? But then the question is, if we have a multi-map, let's search for these occurrences here. So let's say we add here this to the multi-map. Then the question is, how do we even if we have a multi-map, how do we know which to access? Oh. Okay, for starters, let's go here. Simple name to index map. Let's see, how many do we have of these? Executable. Okay. Okay, let's create a new one here. It's called multi-string to index map, and we call it multi-map. It doesn't work. It does work. Good. And it's not multi, it's multi-string. Good. And then we go to executable, and we change this to the multi-map. Okay. Then we search for the references here, and we check what's going on now. Okay, so there is a find, get symbol name, get symbol. So the question now is, will we hit this assert then? Try and place. Multi-string. Where is this function used? Okay, let's see if we hit this assert now or not. Oh, get a lot of compile errors. Includes multi-map. No, map. What does it return? I think it just returns the iterator. It's Okay, so this means it now adds duplicate keys or multiple values for one key. Okay. Now the question is, well, here we just get one, right? Here we just get one. What we could do is, for now, we can say if there is a symbol which has a duplicate name, then we treat it as an invalid symbol. Would that be fair? Right? But then we will run into some asserts. But maybe that's a viable strategy. So if there is a duplicate symbol, we cannot resolve it. We cannot resolve it. Maybe that's fair. Okay, how do we get this? Equal range. How do we use this? Equal range. It returns what? A pair? Ah, right, it's a pair. Auto pair. And we say if pair first is not pair dot second, return null pointer. There are multiple symbols with this name. There are multiple symbols with this name. Unsupported. Unsupported. Then we say if first is found, maybe we put this first. Not found. Not found. No symbol found. Okay. Maybe that is fair. So all the duplicate symbols we treat as, we have them stored here, but we treat them as can't resolve. I'm pretty sure this will hit on some assert somewhere. Let's see. Disassemble. Disassemble. Pseudo symbol. Okay. Multi-map. I've never used this before. Good. But there was another place. Common types. Common types here. Let's search for all occurrences of this one. So it's runner, PDB reader. This one is fair. It's executable. This one we have treated. So it's this one, function name to index map. Yeah. Okay, so we also make it a multi-map here. Function name to index map. We create a map here, map. We cannot reserve. And we emplace. Emplace. Okay. Okay. And now this thing is built here. Multi-string map. More name functions to index map. Functions. Then we do the same thing here as we did in executable. This here. So we say equal range. This pair if first equals and no symbol found. Continue. There are multiple symbols with this name, unsupported. Cannot match by name. Cannot match by name. There are multiple symbols with this name, cannot match by name. But hold on. curious if this is enough. The problem is this might still be problematic, because what if I'm not sure if that is good enough, because we are only checking for duplicates on one side, not on the other. We essentially would need to build a multi-map on both sides, right? Oof. Yeah, I think we need to have another less named functions to index map. Less pair. More pair. No symbol found. Oh boy. Less pair. More pair. Multiple symbols cannot match by name. Const. This is more pair. Less pair. Yeah, so basically we we don't just need to check it on this side, on the other side, but also on our side. If we have multiple symbols with the same name on our side, then we cannot use that to match. Right. Let's put a breakpoint in each of these things and see if they are hit. Yeah. If they're all hit, then they're all legit. Here we have an IT. We need to put more pair. More pair. Dot first. Dot second. More pair. Oh man, this is complicated. This is complicated. This function is complicated, I have to say. It has evolved. Yeah. Yeah. Let's see. String too long. Oh boy. Oh boy. Oh boy. Oh boy. What? Oh boy. Wait. What the hell? Okay, I have the impression we are inserting incorrectly. Multimap and place. No, it looks like we're in place correctly, no? I don't understand what's going on here with like it all shows as empty strings. What? Yo, that is wild. That is absolutely wild. Why is this like this? I don't understand. Excellent. I have no idea why it's falling apart. Something is fishy. Build function name to index. Let me put a breakpoint in an executable. Let's see if the other map was created okay. Here, this one. Let's do this again. Okay, weird things are happening here. That is not good. Okay, so here we have this map, we have edit. Okay, this looks healthy. And this is a multi map. Okay, so this looks good. Yeah. Yeah, this looks good. Then let's go to runner and place a breakpoint here. Let's see what this does. Okay. So map size 0. Okay, so here we have a problem. And place. Could it be that it's so all these names are empty for some reason. Huh. Okay, so there are functions without names as well. Okay. For Okay, so for some reason names are disappearing here. We do something and names disappear. I'm baffled right now. I'm really baffled. Okay, maybe this emplace is not healthy. Can we do an insert? Emplace. std make pair. Maybe we should do that. I'm really baffled. I don't understand what's going on. Emplace. Make pair. I'm really baffled. I don't understand what's going on with this multi-map. I've never seen this behavior. It's really, really odd. Okay, let's see if this changes anything. Okay, so right now we still have functions here with no strings in there for some reason. What about executable? Here, let's make also std make pair here. So we have here a name and we emplace it and it's in there. There we go. Okay. Okay. Something is corrupting here. We get different results. Something is really badly wrong. So now it says out of range std. Now it says something is modifying this. Something is modifying this thing as we emplace. I don't get it. That is wild. That is absolutely wild. I really would like to have an explanation for this. Like, how is this happening? Let's do an insert. Pair. Yeah, insert pair. Okay. And we do the same in executable insert. M is equal number 19. And this has changed. So it looks like something. I don't understand. I really don't understand what's going on here. I don't understand. Let's, for argument's sake, let's make this a normal map again. Multi-string map2. Let's see what happens if we have a normal map again. Okay, it looks like it's already corrupted here. Something has corrupted this, so it's already broken. Yeah. Okay, maybe we have made some error somewhere. Okay, what happens if we hit this with two different files? Okay, then it looks healthy. Okay. Okay, so maybe... I'm a bit surprised that it didn't hit any breakpoints here. What is up with that? Let's restart. Yeah. Okay. One of the sides somehow has 0 elements. How did that happen? Options. How did that happen? Jesus Christ. Okay, so this is build matched functions commands. Where's this called? Yeah, commands. Okay, let's put a breakpoint here. What is going on? I don't understand what's going on right now. We must have broken something. but I don't know what it is. Okay, so here named functions is 0. Why? Why is this 0? Let's put a breakpoint here. Okay, so the result is this. And then it goes in here. Okay, and the next result is 0. Okay, why does this return 0? What did we actually put in? Hold on. Pointer commands, pointer options, executable. Game dots. Why does it only have 419 symbols? Shouldn't it have more? It has a very tiny amount. They should have much more. Okay, what is going wrong here? Symbol named index map. Oh boy, what is wrong? I'm really surprised that things suddenly broke so spectacularly. I did not expect this. Absolutely not. Let's put a breakpoint here. Watch this game dots address 0. Okay, we only get 419 symbols. Why? Why? Config file is empty somehow. Maybe that's why. Game.config.json. It's here. I don't quite understand what we have just broken there. So if we put a breakpoint here, config file somehow is empty. Why? Why is this empty? Probably because this returns nothing. Let's put breakpoints here. Okay, and who would have been responsible for setting this in? Oh. Load async, right. Right. Okay, so what I see here is we absolutely did not set these config strings. And I have no idea why I missed that. I have no clue. That is quite an interesting blunder. wonder if we should have like a helper for this. Okay, so this should fix that problem. How about we create another function for this? Static create a revision descriptor, and the input well, how about we make it part of voids create new revision descriptor. And then we say this why is this complaining? Oh. Once again, I'm stupid. There we go. Okay, make shared, and then we transfer these guys, yeah. Okay. Down here we call descriptor create new revision descriptor, and then we can delete all this. And voila, the code is simpler. Okay. Okay, compare. Now we should have a config name, and there it is. Okay, good. Then let's see if we get better results now. We have this. We still have just 419 because it loads them later here. There we go. There we go. So now it should have 21,000. Yeah. Okay, that looks good. Let's put a breakpoint on the next thing. Okay. Results. Name functions. And we got another name functions. There we go. Okay, good. Compare. Okay, good. Okay. Well, that was an honest blunder. Honest blunder. Okay, so we got a bunch of functions here. And now it becomes interesting. So we got more pair end. So no symbol found. Okay, that's fair. Let's remove this breakpoint. Huh. Huh. Okay. That was unexpected. So it not once hit this. How? Huh. Is that expected or not? It seems unexpected. It seems unexpected. Maybe it's not unexpected because we have already filtered duplicates in executable. Sorry, in executable. Let's put a breakpoint here. Okay, let's restart. Okay. Maybe it's not calling this yet because it's only calling it in a disassemble function, maybe? Could be. End. I'm not sure if this now is necessary, this check here. If this one has duplicates, then we don't match it. But if we ourselves also have duplicates, then we should also not match. Cannot match by name. I think it's correct, but I'm not 100%. It doesn't hit it, so that's not helpful. Not hitting any asserts as well. But that doesn't make me more... It doesn't give me more confidence. It does not. Boy. Oh boy. I'm not sure. Things look strange in ways. So how many matches do we have now? Let me see. It should be around 90 matches. Let's see if that is still the case. Imgui app, create name functions, matched functions. Here, let's put a breakpoint here. Compare. Matched functions, 0. Okay, that is unexpected. Okay, something is broken here with our matched functions. Something is wrong. It never hit here. So somehow equal range. What does this actually return? Equal range. Function name. Equal range. This name, more name function. Okay, let's look at this. Let's restart. Oh. Oh. I think I remember, because we tinkered here and experimented. That's why. Let's do map, 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 map. Map and place. Let's try this again. Okay, more pair. Okay, finally we get some hit here. Okay, good. So first, aha, there are two. Okay, I think this range. I think this check is wrong. I think it needs to be first plus one. Oof. STD advance first. Oh, that doesn't work. Why not? Oh, because it's const. That's why. Still doesn't fix it. Oof. Plus one. Actually, it should be remain const. Why const iterator? It is a const iterator. Okay, how do we check this? Maybe with std distance. Std distance. Okay. std distance, not one. Std distance, it's not one. I think this also means that we probably don't need this check, because this check is implicit with this one, I think. If both are end, then the distance will be 0. So I think we can remove this. Let's see. I've never used multimap before, so that's why I first have to figure out how to use this efficiently. Yeah. Okay, let's see. Okay, so here we now have this and this. My expectation is that the distance is 1. Okay, that's good. And here, oof. And here we also expect 1. Okay, so this worked. Okay, let's see another one. Okay. Okay. Link video stream. Okay, we somehow have this twice, but why? I'm confused. I'm so confused. Poor. Somehow all of these, well, not this one. But we get a bunch of hits here, and I'm confused as to why. Maybe it does not always return end. Could that be? New node hash table. Yeah, maybe we cannot trust these values as we look at these. I don't know what it's giving us, but it's not the input string. Maybe it's finding us something that is near. Subsystem interface. Okay, so how much? Okay, 91, this seems to be correct. I think the result is correct. I'm just curious as to this multi-map, how this works. Okay, but this seems to be good. Matched functions, can we see like what? Ah, no, it just shows us index pairs, which is not very useful. Yeah, okay. And unmatched is... Right. Okay. Okay. I think this is all right. We need to also fix then... Oh boy. Need to fix... std distance first second equals 1. No symbol or multiple symbols with this name. Skip. No symbol or multiple symbols with this name. Skip. Yeah. ImGUI app. Okay. Let's also update the comment in runner. Here, no symbol or multiple symbols with this name. Skip. Multiple symbols with this name. Skip. Yeah. I'm still not 100% sure if this is really necessary, but it could be. Let's think about it one more time. Essentially, if there is a duplicate on the other side, we still need to check if there's a duplicate on our side, right? But then why don't we hit it? Ah, because we don't actually match. We didn't actually match any duplicates. Okay, I think it makes sense that we don't hit this because it's just a very low chance, if a chance at all. But in theory, it would be possible. Yeah, multiple symbols with this name. Skip. I wonder. I think it's okay. Let's keep it here. Yeah. Man, this is insane. Okay. How about How about we run it once without the GUI to see if actually our assembler matching still gives us the correct results. Let's see. This one. Let's run this. Yeah. 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 I hope it's correct. Yeah. Okay, so now essentially we will ignore all symbols that have duplicates. Yeah, these will not be matched because we don't know with what to match. That's essentially the problem. Yeah. Skip. Multiple symbols with this name. Skip. Maybe we should add some documentation here in executable. Using multimap because there can be symbols, there can be different symbols with the same name. There can be different symbols. There can be symbols. There can be multiple symbols sharing the same name. Then we also put this note here in runner. Build function index map. Okay. And let's also do end place here. Okay. Okay. Now there's still one problem left, and that's the case where we saw weird behavior as we compared the same file, right? To me, that indicates that there's some race condition. Some race condition somewhere here. But how can this be? How can this be? We only run the commands on one thread, so there can't be any racing. So we mess something else up. But what? There's some error. Somehow this map is corrupted. But how? We just created this freshly. I don't understand. I don't understand. Okay, that is a really curious problem. Why is this crashing? Okay, so here's a count. So something is corrupted, basically. Yeah, somehow we went. But what is exactly corrupted? Can we see this? Poof. I don't know. Something with the map is corrupted. Yeah, the map is somehow corrupted. But how? I don't get it. I suspect it somehow happens because we use the same input. Named functions is the same on both sides, but how would it be interfering then? The indices look fine. Containers look fine to me. We have two references. They both reference the same thing, but that is perfectly fine. Where did we corrupt? How did we corrupt? The success looks perfectly fine. We M-place to the map. The map somehow is broken. I don't get it. It's a really curious case. The question is, how do we properly debug this now? I have the suspicion that something already happened before. Some problem. And we just, like, it's the effect of corruption somewhere else. So maybe we need to run it against address sanitizer. Oof. Oh. It's as if it's hold on. Could it be because we are no, that can't be. MGUI app. Oh, man. It's probably something very stupid somewhere. That's my suspicion. But it could be hard to find. It could be hard to find. Let's put a breakpoint here. So here we expect load file count 1, and we create a new Thyme.pdb exe, everything auto. Yeah. Here's a copy, blah blah blah. Okay. Da, da, da. Name functions. Name functions. Name functions. Oh. Let's put a breakpoint in here. Okay. Okay, so now these descriptors also named functions build. Aha. Aha. Here we also build this twice. Ah. And then we also call this twice. Aha. But why would it crash? Okay, I see some error here in this logic, because here we also need to check the same way as this one. Here, load file count, this stuff. Yeah. So here is comparing same file, and then we do file descriptor. So it checks, it's comparing the same file, load count, and then we put this here as well, load count, load count. Okay, that should work. I don't know how this explains the crash though. That is not clear. Compare. Okay, so now load file count is 1. Now it goes in here. Okay. Chain. And then it go in here. Then it does this. Now let's see if we get the crash again. No, it did not crash. And now we go in here. Matched functions. Matched functions 326. Yeah, which makes sense. It's almost all right. Okay. Now I would have liked to see the results. Can we see the results? So it doesn't crash anymore. That's good. I don't quite understand why it was crashing then, though. But clearly the logic was wrong. I would like to understand it. Always good to understand why things are wrong. Let me... There should be an update function. I would like to look at, watch this, comparisons. So matched functions, okay, and files. And we have, let's make this larger. We have, we don't have, here. Pandas. Parent pandas. Name functions. We got a bunch of functions that don't have matches. Let's see why. This is the E functions here. Yeah, okay, that's fair. So we don't match the E functions. Yeah. Okay, that's fair. Yeah. Okay, so I see a problem here. Here it shows us all the bundles are efficient. Yeah. Functions. Let's go to code. MGUI app. Async. Here, compare async. And functions built. Aha. Right, so it's referencing the same build name functions. Okay, that's fair. Here we have a problem. Right. Okay, here the problem is I think here we need to actually build it for both. what we can do is I mean, these are two different things. So we could, what are we passing there? Const. Okay, it's all const. Okay, the simplest change here, I think, would be this. Yeah. I think we can do that. Just build it for both. Yeah, okay, then we move this here. Okay. Revision descriptor pair. Okay, I think this is correct then. Let's see. Compare. Okay, it didn't crash. Let's look at it. Comparisons. Files 0, 1, and yeah, we got the bundles here. The bundles will be identical, but they are built individually for both. Well, that's fine. I mean, strictly speaking, the most efficient would be to just copy it from one result to the other, but that requires extra logic, and I don't think it's worth it. We can keep it this way. Okay. This looks good. It doesn't crash. Now, I would like to understand why it crashed. I mean, we fixed it, but I don't yet quite understand why it crashed. Where is it? Here. This one. So essentially, it created this command for the same revision descriptor twice. Yeah, because this one here was the same for both. And why would that be a problem? No. No. I think I understand why. Because if we here, when this succeeded, it built it built it called this here because both named functions build would be completed, and then it called this, and then it went here, and here to create this functions command, it is referencing the current container it has, but then it will do this a second time, and so the container changes, and then the container that was used here is no longer valid, has already been purged. Is dangling, and yeah, it's how do you say, freed memory. And so it will then use it when it gets to work on this command, and then it crashes because, yeah, it's garbage memory. Okay, that makes sense. I understand the problem. To me, this indicates that we forgot placing some assert somewhere. Actually, well, asserts wouldn't be able to catch this. No, it was just a bug. Yeah. It's just a bug. Yeah. Okay, but it's fixed now, so it's good. No problem. Okay. Good. All right, then, yeah, I think we fixed quite a few things today. That's good. Then I will end it here. We didn't yet get to submit the stuff that we have worked on, but let's try to do this in the next session then. Yeah. Okay. Good. All right, then. Oh, that has been 3 hours. Oh, okay. Well, then I wish you a great day or night. Until next time. Goodbye.